My name is Ravil. I am a student of the Physics University in Moscow, and the subject of my report is defense of hybrid coal. I will tell a few words about my objective. The objective is to search of vulnerabilities in HTTP and develop the hardware to find and block the malicious activities. So, in my presentation, the mission was to research the HART protocol and analyze the vulnerabilities inside that protocol and research the concept of the security in STP. Before I will tell you about the HART protocol, I will tell about the what. Okay, so apart from the analog signal in the field, I was also transmitting digital signals. So that's how I developed the HART protocol. This is the industrial digital protocol to transmit digital signal based on frequency modulation. So in other words, there's the combination of the transmission with different frequencies. So 1200 hertz, that's logical unit, and logical 0, that's logical 1. And logical 1 is 12 hertz. So this can be directly connected to leading devices and the medium level, and the first leading LED device is the usual PLK, and the other is hard modem, or the PLK containing the HART protocol devices. The second connections to the two leading devices, you can connect up to 15 different LED devices. Then you can transmit only the digital signal here, and the analog signal is used to power the trackers. So this protocol is vulnerable. Such as the software vulnerability, can cause the failure of the software with this specific HART protocol. And also there was a vulnerability of the server with HART. So if there's the wrong IP header, the HART, the OPS server could fail. The other vulnerability is that for example, the hacker with low impedance could retune the sensor or replace the sensor. So the device was giving the wrong ID, and the other vulnerability is that we know that the system is now connected to the EMS system, so for that we can use there's a LDDTM technology integrated. It works the following way. It's based on containers and COM containers and COM objects, and the interaction happens based on XML messages. So all the information that we have in the sensor, it's packaged into the XML message. And as a result, if the sensor is swapped It's possible to inject the XML code. There are also certain vulnerabilities at the field level, and antivirus or scanners cannot protect that. So we want to develop the hardware that would protect all the three levels of automation. Also, it would have three important points: the technological security for the specialists who collect technical information, technological information from objects and sensors, the security of the production. This is for the specialists who manage the production, and this option would be important. Would give here we would get the information about the problems that would appear if in the case of Sudabi. The third thing is, of course, IT security, the IT security instances, and of course the direct results of that. So the hardware, the software would have certain modules to analyze at the physical level, so which will allow to control the actual physical features of the signal. Next model is the frame analysis. We'll be able to analyze the structure of the transmit packages based on the frames and find the violations of the allowed format. There's a model to analyze the comments, the data transmission. We can initially set the scenario, and if the work happens not according to the scenario, that can be identified. Of course, basic vulnerabilities would like to find vulnerabilities before they have been exploited. The field level protection is based on quick Fourier transformation. Based on the current of the network, we'll be able to build a frequency portrait for each signal, and we'll have the perfect model for each signal and certain thresholds. And if the frequency will be swapped, we'll be able to identify that. So now we're developing here the model, the hardware board and the controller, and we will be making new firmware and testing in the near future.